Okay, so today I want to go over something called the kinetic molecular theory. This theory helps scientists to better understand why gases have the property they do by understanding how the molecules of a gas interact on a molecular level. So before we go over the parts of the kinetic molecular theory, I first want to show you a video.
The kinetic molecular theory explains the behavior of gases by looking at the forces of the particles in the gas and the energy they possess. A gas contains very small particles. They are either molecules or atoms. The distances separating the gas particles are relatively large. The space between the particles allows them to be pushed together. The gas particles are in constant, rapid, random movement. This is one of the reasons why gases immediately fill their containers, and why they quickly mix or diffuse together. Because gas particles are in constant motion, they collide with each other and with the sides of the container, but they do not slow down or lose energy. This is called elastic motion. The kinetic energy, the energy of movement, depends on the temperature of the gas. Temperature is actually a measure of how rapidly particles are moving or vibrating in the material. At higher temperatures, the particles have greater kinetic energy and move more rapidly. At lower temperatures, they have less kinetic energy and move at a slower rate. Finally, gas particles exert very little force on each other. They are like independent agents, bouncing about, uninfluenced by any other particle.
So let's just review from the video. So gases, according to the kinetic molecular theory, consist of hard spherical particles. So they kind of behave like billiard balls. The particles are very small, so in comparison, the space between the particles is extremely large. Because of the small particles compared to the large amount of space between them, there appears to be a lot of empty space between the particles. This large amount of empty space makes it easy to compress gases, and the fact that there is not much attraction or repulsion between the particles also makes it easier to expand gases. And then finally, the gas particles are moving rapidly, so they're constantly in motion. Now, I just want to explain one thing that the video did not really go over, and that is that the reason why particles are moving constantly is because all the collisions between the particles are perfectly elastic. Now, what elastic collisions mean is that they don't lose any energy during the collisions. So when you think about usually in our world, like when you think about a basketball, when we bounce a basketball, if we let go of the basketball and it just continues bouncing, what we will see is that the ball will not bounce to the same height. It'll start to lose height, and then eventually the ball will just roll along the floor and it will stop. And that's because the collisions that it's experiencing are called inelastic collision, where they're losing energy. Gas particles, however, they do not lose any energy. So if you can imagine a basketball, if a basketball were bouncing and it had just elastic collisions, the basketball would continue bouncing after you stopped dribbling it. If you came back weeks later, the ball would still be bouncing to the same height. That's an elastic collision. And most things in our world are not elastic, they are inelastic, where we lose energy.